We are in Eindhoven, the city of photonic integration, and I'm meeting with one of the startups which is about to revolutionize the way that we assemble fibers to chips. The company is called Microalign. Thank you very much for having me here. What is Microalign?
Microalign is a TU Eindhoven startup, and we have a special tool to improve the fiber array to chip coupling.
And how do you do that?
Well, instead of moving all the fibers together, we move each fiber individually at the same time.
Within a fiber array, you can address and move each fiber individually?
Yes, yes.
Oh my God, you need to show that to me. I really want to see
show
it.
you. It's a nice device with MEMS, and we'll show you how it works. Come to the 10th floor.
Do you have an elevator? Because otherwise it's too many stairs.
Yeah.
And now we're at the laboratory. We're going to see for the first time the demonstrator of Microalign. And I'm here with the CTO. Tell us, what are we about to see?
So what we see here is a demo of our MEM actuator, and we have here the optical fibers, and we have our actuator which have a triangular shape, and we can show you that we can individually move all the fiber simultaneously, and in this way we can improve the alignment technique for fiber arrays to chip.
What we are seeing here as a blue spot is the position on each fiber, and you can control it individually.
Yes, that's right.
So what is the application for this?
Well, we have several applications. We have fiber-to-fiber coupling, we have fiber-to-chip coupling, and we have die level testing and even wafer level testing. That's what we have here.
Yeah, indeed. Here actually we see an example of how our alignment stage will be in a wafer testing station. You can imagine this is a kind of a situation in which we have the wafer in the probing station. In the wafer probing station, this is the stage, and the wafer is basically roughly moved, aligned underneath our fibers and actuator, which will be basically in the white square. And then with our final alignment stage, we can actually move our actuators to move the optical fibers so that we can optimize the alignment between the fibers and each chip on the wafer. That's how it's going to look like in the future.
This is where the magic happens. They took me to the clean room because a very important part of Microalign is manufactured here. Simone, why did you bring me here?
Yeah, I brought you here, Jose, because this is a very interesting place where we fabricate one of the main parts of our actually alignment stage. We not only have electronics or software or bulky mechanics, but we also have micro actuators. And this is basically where our micro actuators are fabricated. And here RIAP is doing one of the steps. And at the end of this process, basically we are supposed to have a comb of micro cantilevers to actually manipulate our optical fibers.
It's surprising that you actually make the MEMS in-house. Why did you go for that option instead of choosing external suppliers?
Yeah, you're right, we do the MEMS in the house, and actually we went for this choice because our technology process to fabricate them actually is not standard, and we realized it would take too much effort and time to let this developed outside.
So you're already talking to MEMS manufacturer for the future scalability?
Indeed, we are already looking for that one for future outsourcing. That's true. It's something we are doing in parallel, and we expect that actually in 4 or 5, let's say, months from here, we will be able already to transfer the process outside.